Alright, so now let's code up what we derived in the last video. So I'm going to start off with some definitions here. I like to clear my memory workspace and also the command window. Clear CLC does that. I'm going to define mu as -1. Why? Because generating variates from a truncated normal distribution, if your mu is equal to 0 or some positive number, wouldn't be a problem. If our lower truncation region was 0. If it's -1 though, generating from the positive side of the normal distribution wouldn't just happen very easily or very often. So I'm going to set it equal to -1, just standard deviation 1. So and then I'm going to make a function. Okay, so this is what my function looks like right now. I'm going to return x, but it doesn't do anything. Okay. Now I need to code up what I've written down right here. This is what I want in the end. So do that. Let me do that in a couple pieces. I'll need a uniform between 0 and 1. The default is to give me just one draw. I need a FA, which is the norm CDF of this. Since my lower truncation region is 0, this will be minus mu over sigma. And I also now need to do the equation, which is here. Okay. So u times this 1 minus put this in all in parens and then take the norm inverse of that and then multiply by sigma, add mu. That's what I want x to be. Alright, let's take a look, see what happens. Alright, we get a positive number. Lots of positive numbers. I don't know if you want to test this code a little bit more rigorously, like we can add a n argument to get many numbers. And then to make it more general, we can do n by 1 and add in some dots. Now this should give me many draws with this mu and sigma from this truncated distribution. Let's see what it does. Oop. There. Test it. Take 1,000, make sure there's no negatives. Let's look at a histogram. Make sure that this code actually works. We should see a picture that only has bins on the positive side. And that's what we get. Should look normal, cut in half, sort of, except that our mu is -1, so we should not see like the top of the distribution quite. But we should see something out to the right a little bit more, which is what we get. Yeah, like a couple more bins. Do something like 10,000 draws. See what we get. Okay, looks good. Let's move this mu closer to the negative side so that it'll be harder to produce these draws in using a different way. And we get this still positive, all positive. So this code will probably stop working when I get any further than this. Looks okay. But you can see that it's much harder to get draws at this point. If I went to probably like 8, this probably would not work. Okay. So you can see that it's not working very well. The reason for that is that the norm inverse function stops working. It's not able to distinguish from in this case, I would think that it would be unable to, let me take a look at this, that mu is -8. Yeah, so it's able to distinguish this FA part from, or actually this part, this norm inverse part, from 0, because this is very close to 0 or 1. Actually, this would probably be pretty close to 1. We know that this part would be very close to, if we have a -8, this part would be very close to 1, which makes this close to 0, which just gives us 1. The norm inverse of 1 gives us basically the junk that we're seeing. So that's why. So you got to keep this around this level, and hopefully I don't think that you will, but you probably won't need to take any other measures other than what I've showed you to get draws from this, unless you were doing this for a real model. Then you would. Then I'd have to show you some different code to use. But this is good.